Zoom recording. Okay, so now let's take a look at and refresh our knowledge of proportional and non-proportional relationships. Okay, so proportional relationships we talked about yesterday. We had talked about them a little bit last year. Proportional relationships are equations that pass through our origin, that have a vertical intercept of 0. They pass through that origin. If you have a linear relationship that goes to the origin, you can describe it as proportional. Okay? It does not have a y-intercept. This idea of y-intercept we're going to be talking about today, and we're going to be identifying and defining today. Okay? So a non-proportional relationship is an equation that does not cross through the origin, right? So it has a y-intercept. So if you look at this guy here, this equation starts at the number 20. Do you notice that? Where it hits our vertical or our y-axis at the number 20, it doesn't cross at the number 0. Does everyone notice that? Awesome, perfect. Because we're going to be talking a little bit about proportional relationships, but we're not going to be using the term proportional relationships as much anymore. We're going to be broadening it out to linear relationships. Okay? So let's take a look at the activity number 2, where it's talking about 5.2 slopes, vertical intercepts, and graphs. Okay? So everybody needs to have their Chromebook open for this activity because I didn't want to hand out the paper. So you're going to do this sort. So even if you're at home and you have a textbook, I want you to open up the slideshow for today because we're going to be doing a card sort activity. Okay? So we're going to, on the next few slides, you're going to have 6 cards describing different situations and 6 cards with graphs. We need to match each situation to a graph. Then we're going to pick one proportional relationship and one non-proportional relationship and answer the questions on the slides about them. So let's see what that means. Okay? So on these slides, you're given, the first set of slides has the situations, where we're talking about some scenarios that have some equations that are going to relate from it, right? So for example, Lynn's dad bought a tablet. He pays the same amount each month for a subscription to a movie streaming service. The graph represents how much money he spent Y for the tablet and X months of service. The slope of our line is 10. When we talk about slope, ladies and gentlemen, slope is our rise over our run. Okay, so let's look at a graph and find a slope of a graph real quick. Before I have you work on this activity, we're going to look at one of the graphs on the next page, and we're going to identify what the slope of one of these lines is. So if you're looking at, for example, let's take a look at graph number 5. So I want to identify what the slope is of this line. So my suggestion to you guys is, let me see how it looks. Okay, perfect. Never mind. You're good. So how do we identify the slope of this line? So we're going to draw a slope triangle in. Okay, we're going to find our rise and our run. So we're going to find on our graph where your equation line meets 4 boxes perfectly. So like, for example, we're looking like it meets 4 boxes perfectly right here at our vertical intercept right here at this 9. Do you guys notice that? So it meets those 4 boxes perfectly. Then I'm going to follow this line until it crosses another 4 boxes perfectly. This, if I go over 1, it's not going to be perfectly in between 4 boxes. Over again, not there, not there. But if I look here, it crosses this line perfectly. Do you see that? Do you guys see what I'm talking about? So that is going to be the slope triangle you're going to use to identify your slope. So you're going to draw a little triangle connecting those 2 points. How many did I go up? So now I'm going to count. I go from 9 to 10. So I rise 1 and I run it. Let's count how many boxes using our scale. 1, 2, 3, 4. So my run is 4. And if I write slope as rise over run, the slope of this graph right here is going to be what over what? If it's rise over run, Abby? 1 over 4. So this guy right here is going to have a slope of 1 over 4. So it's going to be your job to identify the slopes of these lines and to actually watch. You might have to do this as well. So when I put these on here, it got cut off a little bit. So you might have to grab this guy on the end and pull it over so you can see these numbers here. Okay, so you have 2 jobs. So you want to identify your slopes for these lines, match them to a situation, and match them here. So you're going to pick 2. So you pick a situation, and then you paste the graph that matches it next to it. Do you see what I'm asking you guys to do? So I'm actually going to give you 10 whole working minutes right now to do these 5 matches. 6 matches. 6 matches. I'm going to give you 10. If we need more, I'm going to give you more. Does everyone understand what I'm asking you to do? Okay, so we're taking 10 working minutes right now. I might extend it if we need more time. Raising hands if you have questions. I'm going to be opening your slideshows on my computer over here so I can see how you are doing. I'm going to go back here so that you can see this example.
Mr. Lockhart, please call extension 3214.
Okay, let me just grab my mouse. Okay, so everybody should be in here. Okay. Nice. Ooh, Cindy is jumping right in. Nice job, Cindy.
Will one of the custodians please call extension 3214?
If you want to maybe on the matching slides, if you want to throw the graphs on there and make them larger so that you can more easily find the slopes, you can do that. Over 1, we will offset from 10 to 15. So what's the difference between the 10 through 15? Well, so this one has a rise of this one has a slope of 1/4, which that's the situation with that one. This one has a slope of 1/4, or that's 1/4. I would make that match, and then I would take the graphs and make them bigger, like fold them and make them a little bit bigger, and then see if you can calculate that rise and run. Okay. So my suggestion to you, if you are having trouble, is I went through and I copied all of my graphs onto each one of the situations. And I made it as big as possible so that I can more easily see and create my slope triangles. Does that make sense? If you're working already, that's fine. You don't have to do this. I'm just saying, if you're struggling, this might be a good way to go with it. Ready? We're gonna take about 30 more working seconds and then we're gonna come back together because I want to, I don't want to leave people struggling for too long if you are struggling, and I want to come back together and go through this. So we're gonna take about 20 more working seconds and then we're gonna come back together. Okay, so my friends at home, let's come back and be ready to flip back and forth between this slideshow and the Zoom session because we will be going through these all right now. So let's take a look. I want everybody to pull up their graph number. Let's look at graph number 1. Let's start with graph number 1. So my job to find the slope is I need to draw some slope triangles in. I have to look at this line and I need to say to myself, where is a point that it crosses 4 boxes perfectly, or where does it fall at a perfect easy number here? It falls right on my vertical intercept here, right on my y-axis. And if I follow it over, oh, it falls right here as well. And look at that. If I draw my slope triangle in here.
Andy, please call extension 3214. Andy, please call extension 3214.
I already know that this run is going to be 1 because this 2 boxes, if I look at my scale down here, I know that this run here is going to be 1. And what is my rise going to be? And 5. Because if you look at, let's see how we know that. We went up 1 box and the scale on this graph is by 5s, right? We notice that looking at this one? So this has a slope of what over what, Junior? Rise over run, so it's going to be 5 over 1. Kyle. Looking back at the situations up here, which situation had a rise in our slope of 5? And Diego's situation, very good. If you look at the last sentence, the slope of the line is 5. Did everybody see that? Does everybody see that? And does everybody see why we made that decision? So we're going to come back to graph number 1 and we're going to make that match. Does everyone see why we made that match? Okay, good. Now let's take a look at graph number 2. I need somebody else's help right now to help me find this rise and this run here. Okay. Wait, I'm going to do a different color. So, nice job, Dave, on that one. Who can help me to find a slope triangle here? Gwen? Where does it hit 4 boxes perfectly? Where? So at 60, okay. Don't make it too tricky. It hits 4 boxes perfectly at our y-intercept, at our x-axis here. And then I want you to follow it along the line and don't go a bunch of boxes out because you're going to get a rise and a run that you're going to have to simplify. Don't do that to yourself. You say, following this line right next to it, I look over and when I have a run of 1, it fits it perfectly here as well. Do we see that? So we have a run of 1, if you look at your scale, and a rise of how many? Looking at the scale. John? 10, very good. So my slope for this line, my slope for this story is what? Gabe, what is it? $10, very good, because it's 10 over 1, which is 10. So which situation has a slope of 10? Kyle. Owens. Which one? Oh, situation A, perfect. Let me make that match. Oh, Lynn, you said. Here we go. Graph number 2, we're making that match. Good. Now let's look at graph number 3, and I'm going to get people's predictions for the slope of this one before we go through it together. So what did we think? I want to have 3 people tell me, what is the slope of graph number 3? Max, what did you think the slope for graph number 3 was?
I think the slope for graph number 3 is 15.
15? Okay. Who else did it and has a slope that they had for this? Gwen. Abby, what were you thinking? Abby was also thinking 15. Let's see if people at home. Connor said 15. Gabe said 15. Awesome. Let's test it. Okay. So we can always, not always, but I can look at this graph right here and it hits perfectly right on my y-axis again. If I go over to 1, is it going to fall perfectly there? No, don't do it to yourself. Don't do it. I'm going to go over to 2. Oh, and over to 2, it falls perfectly between those boxes, doesn't it? So now we have to draw our slope triangle in. This time, what is our run here, Sadie? Our run is how many? How much? But it's 4 boxes, but what's the scale? 2. And then what is our rise here, Cam? We're going from 40 to 70.
30.
30, very good. How would I write this as a slope fraction? What over what? Nice job, Gabe. Kyle. 30 over 2. We want to simplify it because they're both even numbers. So what does this slope simplify to, Adam? Oh, I thought you had your hand up. You didn't? 15, very good. 30 over 2 simplifies to a slope of 15. Very, very, very good. Does everyone see how we did that? Awesome. Okay, so then which scenario or situation does graph 3 match up with? Looking back up here, it has a slope of 15. Which guy does this match up with? Whose story? Cam. Noah's story. Very good. So I'm going to hit Control X, cut it out of there, and we're going back to graph number 3, and we're going to paste it in here. Nice job. Now let's look at graph number 4. Graph number 4. I should pick them in order. Okay, this guy's a little bit tricky. What did we think the slope was for graph number 4? Abby, what did you think it was? I think 40. 40? Gabe also agreed with 40. Payne, what were you thinking?
I said 40.
Also said 40 as well. So what do I have to do to find the slope of this line? Do what, Max?
You have to find an area where the line is directly on a point.
Perfect. So I would say maybe the 0, 0 is a good one to go. And then I can go along my line. I'm going to go over to 1. And does it cross perfectly at 1, a run of 1? If I look at, if I follow it along, does it cross perfectly? It does, right? So we would have a run of the 1, very good, because it's right. If you look at the graph here, the scale, what would the rise be? Sadie, what do you notice the rise is here? It's going to be 40. So if I have a rise of 40 over my run of 1, what's my slope gonna be? Junior. So it's gonna be 40 over 1, which is equal to 40. Nice job, Junior. So which scenario, which situation had a slope of 40? If we look back here, which scenario had a slope of 40? Lynn's mom, very good. Here we go. Okay, so awesome job with this. The last two, we're not going to go through it this time right now. We're going to move right into which one of these graphs here. What type of relationship does this graph show? A proportional or a non-proportional? Why?
Because it starts at the origin.
Because it starts at the origin. Very good. This one is a proportional relationship because it starts at the origin. Adam, what about this one? Let me just switch it. Give me 1 second. Sorry, guys. What about this graph right here? Adam, what do you think about this one? Why do you think it's proportional? Proportional means it goes through which point? Well, not exactly. There's a specific spot on the y-axis that it has to go through. Proportional means it goes through the origin, 0, 0. Does this guy go through the origin? So this is non-proportional because it doesn't go through my origin. Now, let's see, Cindy at home. What about this graph right here, graph number 6? Is graph number 6 proportional or non-proportional? Throw it in the chat for me. Let's give Cindy like 30 seconds. Perfect. She said it's proportional. And why is it proportional, Kyle? Why is this graph proportional? It goes through. No, it's not. It goes through the y. Not all equations, but most equations are going to cross that y-axis. It has to go through a certain spot on the y-axis. Where? It goes through y equals 0, which is the origin. Very good. It has to go through the origin to be considered proportional. Okay? So let's take a look at the last activity here. We're not going to do these two slides, 17 and 18, we're not going to do. Let's take a look at, if you're in your text, why don't we flip our page to 5.3, summer reading. We're looking at 5.3, summer reading.
Yes, we call section 3214.
So we have summer reading, and Lynn has a summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes. Lynn makes this graph here to track how many pages she'll read over the next few days. So she started by reading how many? So before she started her challenge, how many pages had she read? 30. So that means we should cross our y-axis at what number? 30, right? Because if we're starting at 30, it should cross our y-axis at 30. Is this graph correct? No. Where should this line start here? Kyle? Between the 20 and the 40. Very good. So it should be starting here. And then if I read, how many pages does she read each day? Abby? 40 pages. So that means I need to go up how many pages? Up 40. So 10, 20, 30, 40. And I have to go over how many? How many days? For every how many days? 1 day. So that first point there is correct. So from that point, if I want to extend this line, I'm going to go up how many more pages? If I go 1 more day, I'm going to go up 40 more pages. 10, 20, 30, 40. And I go over how many days? 1 day. So if you see now, these are the correct points for our graph. I threw a ruler in your undercarriage. I want you to take these points on your people at home. Give me 1 second. If you have a slideshow, give me 1 second. I'll tell you what to do. I want you to take your ruler and connect these new points to create your accurate line. Okay? My friends at home, if you look at the next page here, if you look at the next slide, we have a line here. Let me erase this real quick. Oops, I clicked the wrong thing. Okay, so we wanted to start at 30. So I'm going to move it so that the end of our line is touching the 30 here. We're going to go through this point right here. So we're going to pull that line so that it goes through that point. Do you see? Let me show you. So it's going through this point right here. So you're going to start the line here, and then you're going to drag it in so that it goes through this point right here, so that it looks like mine. Does everyone at home see how I did that if you don't have the book? That's Elliot, and I think that's really everybody. Elliot, did you see how I did that, my friend? Oh, you're here, sorry. Okay, so we had to correct our line. So we had to sketch the line showing the original plan. So I put that line on there for you. Now we're going to answer some more questions. Okay. So we're looking at this idea, we're introducing this new idea of the vertical intersect. Okay. And the vertical intersect is the point where the graph of a line crosses our vertical or y-axis. Pretty self-explanatory. You're looking at your vertical or your y-axis. Where does my equation cross that line, cross that axis? And it's going to cross, and you write it as a coordinate over. So it's going to be 0, comma, and wherever it hits. If you look at this line right here, where does this equation cross our y-axis? 0, comma, what? And which one? -6. Very good. Now, my friends that are in school, where does this equation cross our y-axis? I'm going to hold her up for you. I know, I'm coming. Going over here. Where does it cross our y-axis? Abby. How would I write that as a coordinate pair? 0, comma, 1. Very good. So, using what we know about this idea of a vertical intercept, or I'm probably going to use it more as a y-intercept. In this story about Lynn's summer reading, what does the vertical intercept mean in her story? We're looking at question number 2. What does the vertical intercept mean in this story, Junior? What page she started on? Very good. So what page number did she start on? Okay. You could also, if you're talking about you're going and you're getting a gym membership for yourself, the y-intercept would be how much is the down payment to join the gym, right? And then if we talk about the slope in this situation, what does the slope represent? The rise in the run. What does it represent in this story, John? What do you think? Our slope, so our y-intercept was 30 pages. Our slope was what? Who can first tell me what was our slope value? The rise and the run, Max, was what?
40.
40. And the 40 represented what? Abby? Each day. Very good. You had both pieces there. How many pages she read each day. Both pieces need to be there because we're talking about something per something. Number of pages for every day. Good. Wonderful. Everyone seeing what we're doing here? Okay. Next one we're going to look at. Let's see if this question is in our text. So this next question is not in our text, but we're still going to look at it. How did your graph compare to Lynn's? So let's look back at the graph that we drew versus the one that Lynn drew. How are they similar? Peyton.
They're all using, like she's still using the same numbers that we used, but she didn't start on the 30 pages that she already read. She just went to the 40 pages, how many pages we read each day.
So she plotted, she got her vertical intercept and her slope sort of confused. She got them mixed up, right? Because she started at the 40, but the 40 was really that slope or that rate of change, that constant rate of change. Good. How else are they similar? How are they similar? That's how they're different. Well, I mean, yes, they're both using the same numbers, so that's how they're similar. How else are they similar, Ian? They're both linear. They're both straight lines. What do we notice they have in common? Abby? They're both non-proportional. Yes. They also have this point. Wait, let me see. Okay. They also have this point in common. They both meet at 1, 70. Okay, so that's how they're similar. They're different because they have different slopes. They have different y-intercepts or vertical intercepts. Good. And what points does our graph have in common? We already talked about that. Who can tell me the position that they have in common? What point do they have in common? Reading it to me in a coordinate pair. And it's over, comma, up. X, comma, Y. 1, 70. Very good, Ian. Perfect. Okay. So we have our activity synthesis for today. Let's look at the closing sort of summation of this lesson here. So lines have a slope and a vertical intercept. The vertical intercept indicates where the line meets our y-axis. A line represents a proportional relationship when its vertical intercept is 0. When we meet at the origin, it is proportional. Okay? So your homework for tonight, ladies and gentlemen, is finishing up that Alex work from yesterday if you didn't finish that homework assignment. And there's an exit ticket linked into the homework assignment. You are going to finish both of those and hit turn in for today. Is everyone clear on what we're doing for homework this evening? For homework, yes, for homework. Okay, so my friends at home, wait one moment before you leave. I'm gonna throw you guys into the waiting room and you will be joining us back for science after CCR. If you have to go to Spanish, you can go to Spanish.